In example 6, we have a pattern with 3 figures, and we want to create a table. So when we do pattern questions, it's really important that you pay attention to how they're counting here. And here they're counting the number of shaded squares and the number of white squares. So if we want the number of shaded, if that's the top row in our table, that's the independent variable. And then the bottom row in our table here will be the dependent variable, which is the number of white squares. So if there's one shaded square in the first diagram, there's 1, 2, 3, 4, 5 white or unshaded. For 2, we can count 7. For 3, there are 9. That's all we have. So we want to complete this table for the first 6 diagrams, but we're only given 3. So we're looking for a pattern here. So if we look, our number of shaded squares is increasing by 1 each time. The number of white or unshaded is adding 2, so increasing 2 each time. So if that pattern were to continue, 9 plus 2, figure 4 would have 4 shaded squares and 11 white. Add 2, figure 5 would have 13, and add 2, figure 6 would have 15 white squares. If we want to write an equation now, well, if we look at our independent, it's increasing by 1 each time, which is what we want for writing our equation. Then this increase by 2 each time becomes a clue as to how to write our equation. So if we want to figure out the number of white squares here, for example, we would have to multiply the number of shaded squares by this value 2. So 2 multiplied by the shaded squares. Then we have to figure out, do we need to add or subtract anything here? So let's do a test here. If we multiply by 2, 2 multiplied by 1 is 2. To get to this 5, I need to add 3. Test it on a couple. 2 multiplied by 2 is 4. Add the 3 is 7. 2 multiplied by this 3 is 6. Add 3 is 9. There's our equation that represents this pattern. The next thing we can ask you to do is sketch a graph. So once again, we need a title. It doesn't have to be fancy. Pattern of squares is fine. We should also label each axis. So remember, this is our independent axis. This is our dependent axis. So on this horizontal axis, we're going to put shaded squares. It was the first or top row in our table. We start at 0 where the 2 axes meet, and then we can increase by 1, 2, 3, 4, 5, 6. On the side, we had white squares. And we need a number to increase by. We had to go as high as 6 and 15, so 1, 2, 3, 4, 5 is not going to cut it. But a scale of perhaps 3, 6, 9, 12, 15 would be sufficient. So we kind of choose our scale so that each block represents an equal increment. So in this example, each step up of 1 represents 3 white squares, and that has to be maintained in all of those blocks, even the first one. So when we plot our points. So one shaded square, was 5, so that's just a little bit below 6, so we'll say here. For 2, we had 7, so that's a little bit above the 6. For 3, we had 9. For 4, there were 11. For 5, there was 13. And for 6, there were 15. So I can look at those points and say my graph is linear. And then the question is, do you connect the points? Well, this is discrete data. It doesn't make sense to find 0.5 shaded squares in my diagram. I either have a shaded square or I don't. So in this case, we leave our points unconnected.